Today, we will demonstrate how to use Pig and PigLatin for data processing. Pig is a component in the Hadoop ecosystem. In fact, it's a layer on top of the core components, the MapReduce and HDFS. Pig uses PigLatin as a data processing language. Pig offers several advantages compared to MapReduce. One of them is the simplicity. You'll see that with a few commands, you can achieve the same tasks that you can perform with a long programming code in MapReduce in Java or even in Python. However, we should note that when you execute those Pig commands, they are compiled into a set of MapReduce tasks. So the execution is a little bit longer. So the advantage is simplicity. The disadvantage is a longer execution time. During this tutorial, we will learn how to create bags. The bag is a fundamental structure in Pig, and how to load files into those bags. Then we'll do some data processing and manipulation of these bags. We can group them, we can join them, we can filter records, and so on. Finally, we're going to close this tutorial with a demonstration of word count, the famous word count algorithm that we saw with MapReduce. Before we start, make sure you check datapower.com/pig.html to download files that are necessary to perform the task. Let's start. Let's suppose we have two files, visitor log and PageRank. The visitor log file records how much time each visitor has spent on each website. For example, Aubrey has spent 5 minutes on Google and 10 minutes on Reddit. PageRank shows the ranking of websites. Reddit has a ranking of 22. Google has a ranking of 85. Yahoo a ranking of 75, and so on. These are fake rankings, by the way. We just made them up for demonstration purposes. The overall goal is to calculate the average ranking of the websites that are visited by each visitor. For example, since Aubrey has visited Google and Reddit with their respective ranking of 85 and 22, the overall ranking for Aubrey is calculated as the average of 85 and 22 should result in 53.5. To be more accurate, the weighted average would be a good measure here, but for demonstration purposes, we are simply going to keep it as simple average. You may want to try the weighted average on your own after you watch the video. Let's start by performing some data loading and processing with Pig. The cluster is up and running. In the previous tutorials, I have demonstrated how to set up the cluster and get ready for data processing. Make sure that the Pig component is already selected when you clone or create a new cluster. Now go ahead and visit datapower.com to download the working files. Click BDME for Big Data Made Easy, and you'll find the section Pig and PigLatin, and I suggest that you download all the files before you run the tutorials. Here is the visitor log, and here's the PageRank. I also have provided the employee part-time and employee week are files that are used in Part B. Here I have also shown all the commands that I'm using in each part, A, B, and C. During the demonstration, I'll simply copy and paste those commands, but I'll make sure that I also explain them when I execute. So let's go back to the first file. I'm going to copy this file and then simply create the same file on the cluster. Now we go back to the terminal and perform several commands. Let's do a nano visitor log and paste. Here is the records. Let's do a Control X and Y for yes, and the file is created. Let's create PageRank. Let's go back to the website. I'm going to copy these. And paste. Control X, Y, hit enter, and the two files are created. Now let's move these files into the distributed file system. So let's create a directory. Let's call it PG. Let's create a subdirectory called PartA. Let's also create another subdirectory called input. This is where the visitor log and PageRank will be placed. Let's do a copy from local, so Hadoop fs, copy from local, and here I'm going to do visitor log to PG PartA input. Let's do the same thing, but for PageRank. So I have both these files in the subdirectory input. Now let's start Pig. Simply type PIG, and the grunt shell will be displayed. As I said earlier, the commands are already here. I'm going to simply copy and paste them to save time. So visitor, I'm going to load the visitor log into a bag called visitors. Let's paste it here. So visitors is a bag where we load the visitor log that we have placed in the subdirectory input. We use pig storage and indicate comma. Remember, the fields are separated by comma. And also we name those fields as name, which is a character array, a site, character array, and the time. This is for the time that visitors have spent in each website, which is an integer. We enter. To see that the data is loaded properly, let's run a dump visitors. You see the execution of MapReduce jobs taking place, and the results will be displayed. That shows that the records are loaded properly in the visitors bag. Let's do the same thing. Let's use another bag called web pages. We take the page rank that we already placed on input, comma separated. The name of the fields are the site and the rating, which is a double, which is that means a number with decimal points. So once we have that, let's paste this command and execute to make sure that it's done correctly. Let's do dump web pages and see the results. Great. Now let's join these two bags by the site. Site is one of the fields in each of the bags. So we write visitors web pages. This is a join function here. Let's paste it here and explain. So we create a new bag, visitor web pages. We join the visitors and web pages. The visitors is the field site that is used to join. On the web pages is also the field site that is used to join. So let's do a dump visitors underscore web pages, you should see the results. Now let's group these records by the visitor name. So let's write a group by statement. So I'm grouping the visitor web pages by the field name. Let's see what happens. Let's do a dump so you can see the results of this function. Visitor. So we have visitor Gina, John, Lisa, Aubrey, Liana, Marley, and their records. So now let's calculate the average rank for each visitor. So we create a new bag called average_rank. This takes each record, so for each group by visitor, each record in the group by visitor, we generate the visitor web page and the average of visitor web pages dot rating. And we call this average AR, average rating. So let's copy and run it here. Let's do a dump to see the results. You'll see that the very last field actually shows the average ranking of each visitor. Notice Aubrey is 53.5, 53.5, as we calculated manually at the beginning of the tutorial. So let's do a top rank in order to list all the visitors with an average ranking above 75. So we filter average rank, where AR, the new field, is 75 and above. Let's do a dump. Here we have all the records where the average ranking is above 75. We can also store the results back into the HDFS. This is the command that we use. Let me paste it. So we want to store this new bag, the top rank, into PG part A output. This is a subdirectory that does not already exist. And then we indicate that we want to store it using Pig Storage, which is a utility for storing data from Pig, and indicate that the results should be comma separated. Once the process is completed, you get the message successfully stored 2 records. Now, in order to see the records, we need to exit Pig and check the record in the output. So we do a quit and then do a Hadoop FS ls. Let's do that. Here we have Pig, so let's do Pig, and we should have a directory called part A, subdirectory called part A. So let's go inside that. Should have a subdirectory called output. There it is. So if it's an output, the results are stored in this file here. So if you do I'm just going to do an asterisk here and a cat to see the results that I have placed back in the cluster. That's it. Hope you enjoyed it, and let me know if you have any questions. If you want to learn more about big data analytics, subscribe to this channel. Also, follow me on Twitter at Professor Benny or join my LinkedIn network. You can always email me with any questions.